Howdy folks, John here from rchelicopterfun.com. Nothing too exciting today. We are doing a repair to the K130 micro heli that I had crashed during a review over 2 months ago now. I don't know where the time has gone. I ordered parts up, but life got in the way. So finally getting around to it. And I just thought I'd share the repair process in case anyone's interested. Not only in the K130, obviously if you've got one, some of this will apply directly to it. But I'm just going to show you my post-crash analysis process, which will help you minimize missing any damaged parts when you make your parts order. And honestly, whether it's a micro or something larger, like one of my bigger machines like this turbine here, I would follow the same process. Obviously more items to check on something like this, and yeah, you cry longer after you crash it, but the same basic procedures would be followed. One of the most important things you can have post-crash analysis is your manual for your heli with all the spare parts. So you've got a listing of the parts, and you can just, as you're going through stuff, you can make a note of it. You can write a part number down if you want, whatever works for you. So the first thing is the canopy on this got all cracked and beat to hell when it crashed. I've taped it up, but obviously we wanted to order a new canopy. The landing struts were broken and the pins had sheared right off. And obviously when it crashed, this thing got torn out of the helicopter. It tore the ESC out. One of the first things we noticed is it has torn out the little pin from the connector, but everything looks okay. It's not damaged at all. So this little pin should be able to slide back into the connector. We'll do that. And it pulled out one of the 3 motor wires, the blue one here. So we're going to plug that one back in. I just plugged that connector back into the board, and yeah, just have a quick look over all the wiring, make sure nothing's come out, check where the wires are soldered to the board, make sure they're not pulled out or fraying or anything. Let's plug the battery in. I've already got the radio turned on, and just see if the ESC is even still working. Just throttle it up a bit. So the ESC is working. Check the tail motor. It's working. Now obviously it's going to be crash dependent. When this went in, the front of the heli took most of the force. Nothing was damaged on the tail, so we know the tail is fine, so nothing really to inspect there. So ESC is good. We don't have to order a new ESC. The motor is working. That's all good. Now the next thing to check are the servos. They strip out easy, and the easiest way to tell that is just to manually move. And if they move with no resistance or they're grindy, like this one, that one shot, this one shot, the elevator at the back, it's good. So if you can move the servo full throw and you just hear the gears moving and there's resistance, there's nothing grinding or anything, which would indicate a missing tooth on one of the gears, we're good. So this servo is good. These two are crap. So you could order new servos. I'm actually just going to order servo gear sets because you can just replace the gear sets. When we had it spooled up, the main shaft looked okay, but I'm probably going to order a main shaft. One of the blades was completely shattered, and usually if you shatter a blade, there's a good chance the shaft is going to be bent. We'll check the gears. There's no teeth missing in the main gear. Make sure none of the linkages are broken. A lot of times you'll crack one of the ball links. So you just want to check all of those, make sure they're still good and strong. Check the main blade links, all your links and balls, just go over them real quick. The washouts, they're in good shape, they're not cracked. The other thing to check is the feathering shaft. These often get bent in a crash, and this is just a little tip right out of my Setup and Tips ebook for anyone who's got that ebook. And you turn the feathering shaft, and if the feathering shaft is bent, as you turn it, both blade grips or one of the blade grips will oscillate. As I'm turning this, hopefully you can see this, this blade grip is oscillating. And that's telling us that the feathering shaft is bent. So we've got to order up a new feathering shaft as well. Just check the frame and everything. The pin sheared off from the landing struts in the frame. Now this one is nice because they've, you can get, there's holes in the top of these, so you can get something in there to push the busted pins out. There we go. If you didn't have that, yeah, you'd either have to drill them out or try to figure out how to dig them out, and if you couldn't, yeah, you might have to order a whole new frame. But the frame looks good. The canopy pins, sometimes they will snap off, but they're okay. Ooh, there's a little canopy grommet on there. So we've got to order a canopy, the landing struts, gear sets for the servos, main shaft, and feathering shaft. The heli came with spare blades, so we don't have to order spare blades. So you just want to make sure when you get all your parts. So there's our landing strut, our new canopy, our feathering shaft, our head axle, came in a package of 2, and our main mast, or main shaft. A bunch of gear sets. I ordered, these were quite cheap. I ordered 4 of them, even though we only need 2. My T-Rex 150X uses the exact same gear set, so I wanted to have some spares for it as well. So now that we've got our parts, let's start repairing. One other thing I mentioned when I was doing the review and when I was flying it is how notchy the collective felt, and I thought maybe the blade grips were sticking, and yeah, they are. You can feel them cogging on the bearings. There's just too much preload on the bearings. Let's get the servos out of here, I suppose. There's a little servo keeper on the top with a Phillips screw in the top. Now to get into the gear set, just have to take the 4 screws at the bottom. If you've never opened up a servo before, it can be pretty intimidating. Anytime you've got push rods that go to a specific servo and a specific quadrant of the swash, and they're adjustable push rods, mark them so you know they go back to the same ball on the swash and the same push rod. So I usually just take a felt pen, I'll mark the ball, the push rod, and the servo arm. And if you wanted to, you could use a different color for the other side. So we will take the servo off of the push rod, just leave the push rod attached to the swash, and we will take the servo arm off, and then just hold on and pull this straight out. And yeah, there's lots of little gears in there. Now, whether you want to take a photo of it when you pull a servo apart so you know where all the gears go, or if you're just kind of gifted at knowing how gears go back together in gear cases, you can probably figure it out yourself. But let's try to figure out which gears have stripped here. And yep, it's the common one that strips on these, and that is the output. Come on, focus, you little bugger. Hopefully you can see all the strip gears in there. And of course, when you're in here, check all the others, turn them. So it gives you every little gear and also the shafts. So you just want to locate what's broken. So this is what goes down into the potentiometer. That's the bottom here. And then we've got, gotta find which gear this is. I believe it's this one. So we'll put him on next. So now we've got to get this on as well. And yeah, it's a press fit. There's some little rasping on the top of that shaft, and that's what bites into the output gear and spline. Now, if you can, you want to get it so it's kind of in the same exact position as what you took out. So your servo will more or less hopefully be centered when you put it back together. You can see there's the flat, and the little tab on that output shaft is right there. So it's kind of pointing to the corner of that flat, if that makes any sense. So I'm gonna, when I put this together, I'm gonna want to try to line up that flat. And we'll get the corner, or that little nipple on the corner of the flat. Try to get it lined up as close as possible, and then just press it on. This is where it gets tricky, trying to fit everything back together. We've got our new gear in place. What you want to do though is find where the center of the potentiometer is and make sure the little travel dimple here is facing out, because it'll get hung up on a gear if it isn't. You'll see when this is back together. So what I do is I just put this spline shaft into the potentiometer, and I just want to find the travel range of it. And you probably can't see this, but this little dimple is way back here where I don't want it. I want it more like about there. So let's see, so there we go. So now there's full travel counterclockwise, full travel clockwise. It stops, the potentiometer stops, and you want that little dimple on the outside. And now we just have to try to fit it all in here. Just want to lift it up, get that gear underneath it, put her back in. We're missing this little sleeve. Bigger servo would have an actual ball raced bearing there. Where's the arm? Now we don't know where the center position of the arm is yet. Hold it nice and tight so the shafts don't come into place, and then just move the servo arm back and forth. Everything's nice and smooth. So that one's done. We just have to screw it back together. I'll do the other one. We'll come back when it's finished. Got the right size servo done. It actually had 2 broken gears. You can see the little tooth missing on that one, and there's that one. The tooth is kind of on top of the gear. So you never know until you open them up. And yeah, if you figure that was just too much hassle, these servos don't cost much, 10 or 15. So you decide if it's worth changing. I don't mind changing them though. So now what we're going to do is power it on. Now it would be nice to think that it'll be perfect, but geez, that looks pretty good, doesn't it? Holy smokes. So I think we got that one good. So that's, again, that's why it pays to, when you're putting that potentiometer gear back on, is if you can get it as close to the position it was when you took it off. Might not even have to re-level the swash plate here. So as you can see, this is fiddly as hell. And this is the one big downside to micro helis. So much easier working on a larger helicopter. But it is what it is. Come on, you little bastard. Ugh. And see if we got lucky on the green side here. The right side. So our green isn't quite as level as the red. As you can see, the swash plate is sitting high on this corner. It's not level. Depending on the helicopter, you're either going to have to level the swash by pushrod adjustment or leveling adjustment within the flight controller flybarless system. Okay, let's get the landing struts on so everything's not flopping around here. So getting to the rotor head here, just going to pop the links off. Now if these were adjustable links, like on a larger heli, where these are actually adjustable push rods, just like these push rods, you'd want to mark them for which blade grip they go to, because that would affect your tracking. But we don't have to worry about that on these simple little micros. So whatever type of screw is in your feathering shaft, these use just a flat bladed tip. More often though, they're hex drives. You just get 2 flat bladed tips and you turn counterclockwise against each other, if that makes any sense, so you can get your feathering shaft out. Yeah, and with the preload off, there's no more notchiness in here, so yeah, There was way too much preload. Okay, there's our little screw. Blade grip comes off. And then this will pull out, hopefully. There we go. And just make sure you don't lose. There's going to be dampeners in here. These are probably just silicone. You want, and then there's our little preload washers. There's the other one over here. So don't lose them. And then we'll get the old shaft out. On larger helicopters, you'd have thrust bearings. This would be a lot more complicated process. So here's our new feathering shaft or head axle, whatever you want to call it. Just compare it to, appears to be the same beastie. So we will put it in. Actually, let's lube it up first. So you could use silicone oil. I'm just going to use some of this light silicone grease. And we'll just slide that through the head. Make sure it slides nice and easy. Now, too much bearing preload, right? Okay, you've got options here. One is if you've got lots of spare parts and you've got little washers, you could make your own spacers. Another thing you can do is just get this on a whetstone to make this thinner so you don't have as much bearing preload on the blade grips. Your call how you want to do that. Okay, let's see how we're doing here. That should be okay. I'll do the other one and we'll just see how it is when we're done. The larger diameter goes in towards the head dampener, and the smaller one on the outside so it rides on the inner race of the ball bearing race of the blade grips. And on go our blade grips. And now I just got to get out a little blue Loctite. Dab of blue Loctite down there so we can dip the ends of the screws in. Well, they're such tiny little screws. You don't want to put much on because you don't want to risk this stuff seeping into the ball bearings. So wipe off any excess. You just want some Loctite in the threads. And then we're just gonna thread them in. I got both screws in. Just doing the final tightening here. So we're twisting them against each other. And there we go. And now there's just the littlest tiny bit of notchiness, but not bad at all. That's way better. Leave comments below if you've got a K130 and your blade grip bearing preload is just grossly over tight and you had to either shave those down or put thinner washers in. Yeah, we've got the main mast, but you know what? I don't think the main mast is bent. When I'm turning this, I don't see that head button wobbling at all, which would be a telltale sign of the mast being bent. So I'm just gonna leave it. Everything's back together. Got the wiring harness zip tied here. Got the control board back in place. Got all the wire routing done on this side. Just double checking everything looks good. Nothing is rubbing on the motor. Check all your wires, of course, for any chafing. If anything got damaged in the crash. Sometimes wires will hit gears, they'll rub on motors and wear through, but everything looks good. So I'm all ready to put the blades back on. And I had the blade bolts up in this little recess up here and couldn't find them for the life of me. I thought I dropped them on the floor, and this is a common thing you'll run into. I've been searching for screws before. They get stuck on the motors. You know, you'll be moving the heli around and you'll have loose screws about and they'll get stuck on the side of the motor can. So that's just another tip. If you're losing your screws, you may not be losing your mind. They might just be stuck on your motor. I, again, will use some Loctite on these little screws, not too much. just enough to grab the threads in the blade grips. With the physical repairs all complete, now we just have to double check the setup real quick. I had to remove both these front push rods and adjust them, had to shorten them a bit because of the gear change in the servo. This servo arm is now sitting a little bit high. If I move it one spline lower, it's sitting even lower, so I'm just picking the best position that's as close to level as possible. Had to shorten this push rod by turning the link in. This one was 3-hole turns. I had to do this one 2 turns because this servo arm is also sitting just a tad high off level. But now that I've done that, the swash plate is perfectly level front to back and side to side. And I also had to readjust my mid stick position or midpoint on my pitch curve with my channel adjustment, my centering adjustment output. So now we're producing exactly 0 degrees at mid stick. Blades are lining up, and at full collective, I want a plus minus 12 degree collective range on this heli. So I'm using my 24 degree wedge, which I outline in the Setup and Tips ebook. And at full high stick, just eyeball that up. So we're sitting at a pretty much bang on there, and full low stick, again, eyeballing it up bang on. So we've got a plus minus 12 degree collective range, mid stick exactly 0, swash plate is nice and level, front to back and side to side. Time to go for a test flight. Now we get to see if it's in trim, how well it flies off the bench after the repair. Well, it seems pretty good. That is hands off. Can already tell that sticky collective is gone. So, flying better than it was out of the box. Flying better than new. No surprise there. So, don't get intimidated by repairing a heli, it's easy. Thanks for watching, folks. We'll see you next time.